We are surrounded by computers, right? But have you ever stopped to wonder what's really going on inside that black box? It can seem impossibly complex, almost like magic. But here's the thing, it's not. We're going to pull back the curtain and show you how that entire, vast world of computing is actually built on just two simple, really powerful ideas.
And I mean, that's the real question, isn't it? Your phone, your laptop, these things have millions, sometimes billions of tiny little electronic parts all working together. How could anyone possibly design or even just understand something that complex without their head exploding?
Well, here's the secret. They don't try to understand it all at once. Engineers have this really clever top-down approach they use to tame all that complexity. And it all boils down to two fundamental ideas that let them build these incredible machines one logical layer at a time.
So our first big idea is all about separating the plan from the actual work. The absolute best way to think about this is like building a house. You've got the architect who designs the blueprint, and then you have the contractor who actually builds the thing. Computers, they work exactly the same way.
First up, we have computer architecture. This is the architect's blueprint. It's everything a programmer can see and interact with, without having to worry about the physical guts of the machine. This covers things like the instruction set, the basic commands like add this or move that, and how much data the computer can chew on at once. It's the purely logical view of what the computer does.
And then you've got computer organization. This is the contractor's job. This is all the nitty-gritty hardware that actually brings that blueprint to life. We're talking about the specific memory chips they use, how everything is wired up, the control signals zipping around, all the stuff a programmer thankfully never has to see.
So there you have it. Architecture is the what, and organization is the how. The logical plan versus the physical build. And the most important thing to get here is that the blueprint, the architecture, always comes first. This is an incredibly powerful idea because it means that different companies, like say Intel and AMD, can build completely different hardware organizations, totally different physical builds, that follow the exact same architectural blueprint. And guess what? They'll both run the exact same software. Pretty cool, right? This image really nails how these ideas are layered. You see, at the very top, you've got the high-level abstract plan. That's the computer architecture. But as you move down, you get deeper and deeper into the physical reality of the computer organization, all the way down to the actual logic gates and circuit designs. It's a perfect example of that top-down approach in action.
Okay, so we've separated the what from the how. That's our first big idea, done. Our second big idea is all about how we describe any part of this ridiculously complex system, whether we're talking about the whole computer or just one tiny little component. And we do it using two key concepts, structure and function. Honestly, it's really straightforward. Structure basically asks, what is this thing connected to? And function asks, okay, so what's this thing's job? By looking at any part of a computer through these two lenses, we can understand both what it does on its own and how it fits into the bigger picture. And this right here is the key insight. A computer isn't just one giant, incomprehensible machine. It's a hierarchy. It's like a set of Russian nesting dolls. You can look at the whole computer. Then you can zoom in on just the CPU. But wait, the CPU itself is a system made of even smaller parts. You can keep zooming in, and at every single level, you can ask, what is its structure and what is its function? It's the only sane way to make sense of it all.
So, let's zoom all the way out to that highest level and see how this all fits together. If we apply this idea of function to the computer as a whole, what is its job? Well, despite all the mind-boggling complexity, every single computer on the planet, from a massive supercomputer to the watch on your wrist, really only performs four fundamental jobs. So what are these four big jobs? Well, a computer needs to be able to process data, right? And it needs a place to store that data. It also needs a way to move that data around, both inside itself and out to the rest of the world. And finally, something has to be in charge, a central control unit that plays traffic cop, telling all the other parts what to do and when. Store, process, move, and control. That's it. That's what a computer is.
Think about something simple, like sending an email. The computer processes the words you type. It stores them in memory for a bit, it moves that data over the internet, and this is all happening under the control of the operating system. Every single thing a computer does is just some combination of these four basic jobs. All right, now for the final piece of the puzzle. We've gone from the abstract what and how down to the four core jobs. So now, let's connect those jobs to the actual physical parts you would find if you cracked open your computer case.
Let's start with data movement. The computer has to talk to the outside world. It has to talk to you. It does this through peripherals, your keyboard, your monitor, and through connections like Wi-Fi or an Ethernet cable. This whole job of getting data in and out has a simple name: input-output, or just I/O.
And here it is. This is where it all clicks into place. We can map those 4 functions directly to 4 main physical components. The central processing unit, the CPU, that's the brain. It handles both control and data processing. Main memory, or RAM, is where data gets stored. The I/O ports and peripherals handle all the data movement. And the thing that connects them all? That's the system bus. Think of it like the computer's nervous system, a superhighway of wires that lets every part talk to every other part.
So from millions of parts, we've boiled it all down to just 2 big ideas: architecture versus organization, and structure versus function. And those ideas helped us see that a computer has 4 core jobs, which are handled by 4 core components. This beautifully simple model is the blueprint for basically every computer ever made. It really makes you wonder, though, as technology keeps rocketing forward with things like quantum computing and AI, what will the blueprint for the next generation of computers even look like?